You know that thing where you've just learnt about something and then suddenly you start hearing about it all over the place? Well, that happened to me while I was preparing this video. The subject of this video is manifestation. Have you come across this? It's kind of like positive thinking on steroids. The idea is that if you focus really hard and think about the thing that you really want, the universe will manifest it in your life. It will become real. And this is also referred to as the law of attraction. You might have heard of it that way. So I came across an article that was talking about an experiment to demonstrate manifestation. And the author of the article, Stella G, used as her title, somewhat tongue-in-cheek, I think, a law of attraction experiment that confirmed manifestation is real. Now, Stella did not propose this experiment. She'd come across it somewhere else. She tried it out and she was writing an article about it. And now I'm making a video about her article. It's all very derivative. What I want to talk about is scientific experiments. So I say scientific because when you describe something as an experiment, you're essentially putting that in the realm of science. That's what scientific research does, is it conducts experiments. And the results of these experiments are supposed to tell us something about the world. So let's back up a bit and talk a bit more about how that works. What does science do? For a start, science doesn't prove anything. This is sort of presented as an experiment that's going to prove manifestation is real. Scientists don't talk about proof, or if you do hear a scientist talking about proof, they're being really sloppy with their words. What scientists do is test things. An experiment is broadly based on two positions. So you set up either this interesting thing does happen or it does not happen. And the experiment is designed to test which of those two holds water. And it's not a balanced test. We don't start out assuming the two positions are equally probable. We start out from the sort of status quo, the currently known things about the world. That's our default position. And we require sufficient evidence to knock us off that. So we have a default position and that's favoured in the design of the experiment. You need quite a lot of evidence to push us over the edge to say, oh, that thing that we thought before, perhaps that's not the case. Perhaps there is something interesting here and we should change our understanding of the world, change our theories to take account of this new phenomenon we've just tested. So broadly, that's how a scientific experiment works. It's designed to test between these two positions. And even if the evidence found does support that something interesting is happening, that's not taken as proof. It's supporting evidence, and that position is then provisional. It's accepted, but provisionally, because a scientist's view of the world is always provisional. It's always open to new evidence overturning it. So that's why we don't say that something's proved in science. And what happens next, after the scientist has conducted the experiment, found evidence in favour of their new theory, published it? They have to publish it with a lot of details about how they did the experiment, so other scientists can then look at it in minute detail and essentially pick it to pieces. That's how it works. It might seem very critical and adversarial, but that is how it works because we understand that scientists are human beings and will have biases and pet theories, and science works by having lots of people with different points of view looking at the same question, so hopefully that helps to cancel out some of the biases. Another scientist will look at the experiment and see if they can find an alternative explanation. That's essentially what they're doing, is saying, well, you say it says this, could it say anything else? Could we find another explanation for these results you've got? And that includes, can we just replicate them to make sure that if somebody else does it, we still get the same results? And other scientists who are interested enough in it might find an alternative explanation and conduct their own experiment, including that replication, and then a variation to test their alternative theory, alternative explanation. And this can go back and forth for years. Ideally, what's happening is that you get increasing refinements of the methodology, of the study, of the understanding, as we get ever closer to the truth in an ideal world. So that's roughly how science works. So with that framework in mind, let's have a look at the experiment that's supposed to demonstrate manifestation to us. As Stella G describes it in her article, reporting what she's read, the experiment is to simply pick something probably fairly trivial, anything you like. Think about it really hard and watch out for the next 48 hours, see if that appears in your life. And the experiment that she did was to think about a green Jeep. She imagined a green Jeep, she thought about it really hard, and then watched out for it. And she was, going about her day-to-day life, and that included driving down roads and seeing traffic. And sure enough, within the next 48 hours, she saw a green Jeep. And she says it wasn't quite the shade of green that she'd pictured, and it wasn't exactly the same type of Jeep, but nonetheless it was a green Jeep. But somehow she didn't feel persuaded that manifestation is therefore real. Even though she'd done the experiment and she got the positive result, she got the evidence that she was supposed to get, she still didn't feel that this demonstrated manifestation. And I'm also quite sceptical. So what do we do as scientists in response to this? Well, we look for an alternative explanation. And on my familiarity with cognitive psychology, I recognise this as the Baader-Meinhof phenomenon. And as described in this article, it feels uncanny, but this is a feature of attention. Attention is drawn to something that might be significant to you. So if you've been thinking about something really hard, and then it happens to be in your environment, your attention will be drawn to it. So you notice things that you've been thinking a lot about. It's known as the Baader-Meinhof phenomenon, and also known as the frequency illusion. It was named after a news story that was featured when it was first documented. As I said, as I was preparing for this video on law of attraction and manifestation, my Facebook feed showed up my cousin Polly's latest podcast is on the law of attraction. So there you are. Is it because I was manifesting information about the law of attraction, or did I just notice it because I was thinking about it? I have to say, I'm sorry, Paul, I don't always notice what your podcasts are on. This one, on the law of attraction, something I was thinking about, I noticed it popped out from my Facebook newsfeed. So that's an example of the Baader-Meinhof phenomenon. Stella, in her article, referred to the confirmation bias. And I would say that's the next step. If you take the fact that you noticed the thing, if you take her noticed green Jeep and say, and therefore manifestation is real, I would agree with her, that's the confirmation bias, the interpretation, the conclusion you put on the results of that. If you start out looking for evidence of manifestation and you find something and say, that's evidence of manifestation, you're confirming the thing you were looking for, you're confirming your prior belief. So that's what we call the confirmation bias, when you go out looking for or particularly notice things that agree with what you already believed. That's not science. Science looks to disprove things and tests theories. So I've come up with an alternative explanation for this. It's the Baader-Meinhof phenomenon. It's just you notice things if you're thinking about them more. So where do we go from here? Well, if I was a scientist working in this area, I could work at designing an alternative experiment. But actually, I'm not really that interested in conducting scientific research in this area. So I'll take the other alternative and simply interpret the experiment that I've read about in the light of the alternative explanation being available and say, this experiment I don't think does provide evidence in support of manifestation. That's my conclusion on this experiment. Notice I'm not saying, therefore manifestation isn't a thing. I'm just saying this experiment isn't very good and doesn't support what the author of the experiment thinks it supports. So this doesn't disprove manifestation, it just didn't adequately test it. So we conclude, whatever it was we started from, our beliefs about the world should not be changed by this experiment. And that's all we can really say from a scientific point of view.